right, here we are again, everyone. Thanks for joining us for VictoriaMetrics Tech Talk. This is our second episode on building a PaaS with VictoriaMetrics, or really, this one is going to be about how do you set it up, like really getting hands-on, cold-faced on this. So I know that last time we were on here, Matthias, I think we covered the what is a PaaS from VictoriaMetrics standpoint. What are some ways to build it? What is our quote easier button? Right. So I think that's what we covered. And you've had some fun with the PaaS over the last month since we last talked, have you?
Yeah, that's one way to put it. Yeah. So before working at VictoriaMetrics, I mostly did things with Docker and Ansible. And so I'm mimicking what we see most commonly in the wild. I'm getting to learn and getting way more hands-on experience with Kubernetes.
Awesome. Any major changes that you had in there? Anything that was a big stumper from sort of switching from the one methodology to another?
It's like learning another language, but the cool thing about it is that it's a language that's agnostic no matter where you're deploying. So if you're deploying a workload inside of GCP, they have a different word for load balancer than AWS, and the differences in the load balancers are way different. So if you want a CDN and a load balancer in GCP, it's a part of the load balancer. In AWS, it's CloudFront in front of a load balancer. Whereas with Kubernetes, you can say, I would like one ingress, please. Okay. You have to know what an ingress or a gateway is to articulate that. But once you learn it, it's like on-prem and cloud start to look similar.
Okay. So it's that initial learning curve, learning some of the semantics and operators, and then you get that aha moment where you're like, I'm almost fluent in this, right?
Yes.
So would you say you're bilingual between Docker and Ansible and Kubernetes now?
It's getting there.
Yeah. And I think that seems like a moving target, right? I think is Kubernetes, from what I understand, I've just touched it at the high level, I got to admit, but it seems like it's one of those things that once you think you get it, there's a whole nother world of the next level of complexity. And correct me if I'm wrong, but I've seen what I've talked to a few people that have done it is they unintentionally try to get more complex or do more with it than they need. Like, is that, or am I making stuff up again?
I think sometimes people can reach for it a bit too soon because it is an extra complexity and an extra language. And if like your company is glued into or like super married to whatever they're deploying to now, the scalability benefit might not apply to you, and the like learning another language benefit might not be, or having a common language in multiple environments might not matter because you're only in one environment. But it's still a useful skill to have. And the other nice thing about Kubernetes is a lot of vendors like us have a whole bunch of things built into operators that make it easier to consume rather than if you were just trying to configure the thing itself. So we'll get into it a bit more, but there's custom resources in Kubernetes that we have for making users that you would have to use Ansible and some like Jinja templating otherwise and kind of figure that out yourself. Whereas you can make a VM user CR that's basically make a user that has access to these Kubernetes resources.
Awesome. And today, I think, correct me if I'm wrong, but really our sort of goal today is to go through getting core data stores stood up, starting to collect some dummy data. So the end result of today is we're going to have data flowing into what we're going to walk through deploying.
Correct.
Awesome. And this is going to be a total learning curve for me as well. So you're going to be my Sherpa today. I might jump in with some questions that are silly. If they are crazy, let me know. Otherwise, I'd love to see how we get this running.
Yeah. So here's my terminal for deploying a Kubernetes cluster. So another interesting thing about Kubernetes is there's a bunch of different ways to consume it. There are services from pretty much every cloud provider like GKE, EKS, and AKS. Those are the services from the big three. But there's also a bunch of cool projects for running Kubernetes on your own hardware. And I use a tool called K0sctl, which is basically a YAML file that turns a pile of hardware into a Kubernetes cluster. So here's that YAML file right now.
Right.
Do I need to zoom in? You got closer to the camera.
Yeah, I'm old and have bad eyes, but a little zooming in, there we go. Perfect. Thanks.
Perfect. So this is just defining our cluster. So it's just saying, hey, here's how to SSH into the box. And then when we set up our K0S cluster, we have the version and we have to name the cluster. If you can guess where that name comes from in the chat, please let us know. I would appreciate it. And this is defining how we want to handle networking. You could either use IPVS, which is a Linux kernel module for virtual IPs, or you can use NetFilter. Here is, I'm just disabling telemetry so I don't have to do it at the command line flag. And then one cool thing about KOS or K0S is that you can have it deploy Helm charts for you. So do you know what a Helm chart is?
I have a high level idea, but
yeah. So a Helm chart is basically, I guess I have to back up a second. To apply things to a Kubernetes cluster, you have a Kubernetes manifest. A Helm chart is a way of wrapping somebody else's Kubernetes manifest, and it lets you just poke holes into the settings that they made to change it yourself. Okay. So if somebody has the settings like 95% correct most of the time inside of their manifest, rather than having to edit a giant YAML file with all of their Kubernetes manifest, a Helm chart is a single set of YAML values, and then you could change the things that are relevant to you.
Okay, perfect. So it's like it's in the most basic sense, it's like a find and replace for this configuration that somebody's already put out that is close. I want slight changes. I only have to define the changes I want, not all of the steps, correct?
Correct.
Okay.
If you're coming from, go ahead. Question:
how do you know if the one that you're going to be using is right or needs to change it? Like where did you get this particular, you're running Helm, where did you get the other manifest from? So
I got my Helm charts from the official sources. So in this case, since we're running on-prem, we have to set up some of the things that are done in things like GKA for you, like setting up external IP addresses and an ingress controller. So I picked Traffic because I use it. I was already familiar with it in Docker, and you just search Traffic Helm chart, make sure it's the official one from the vendor, and add it. Same thing for VictoriaMetrics, Grafana for DataViz, and some of the other networking things we need to set up. Okay. So Helm charts come from repositories. So this is just adding all the official sources and giving them a name. And then inside of the charts here, we have MetalLB, which is how we're going to create IP addresses that are accessible outside of the cluster. So when you create things in Kubernetes, by default, they're only accessible in the cluster, and they have their own internal networking for talking to things, which is great for some use cases, but most of the time we're going to need the ability to like send data from another Kubernetes cluster, another application in. So MetalLB handles the IP address side of that. We're using Longhorn for managing distributed storage. So KOS is a very bare bones deployment of Kubernetes. So we need some way of creating storage volumes because by default, containers don't really persist anything across reboots. So we need a way of storing our metrics and logs long-term. Longhorn is a way of giving us persistent volumes that will persist whether or not the pod reboots or not. And then Cert Manager. So even though the traffic proxy can handle managing certificates itself, the most common way people manage certificates inside of Kubernetes is to use a tool called Cert Manager. And what Cert Manager will do is it will handle issuing the certificates, and then inside of your applications or inside of your ingress controller, we'll get into what an ingress is in a second, that will allow you to consume those certificates separately. So rather than having something like Traffic that bundles, or Caddy, which I know you've been playing with lately, which bundles issuing certificate issuance in the reverse proxy, In Kubernetes, you would use Cert Manager to decouple getting certificates and the things that actually need the certificates.
Okay, perfect. And when you started talking about certs, my PTSD, which I just broke again last night, my caddy server that I'm serving around the cert. So yeah, that's perfect. So I could have the same fun in Kubernetes.
Yep. So this is my certificate trauma in these Helm values right here. So if we went and actually looked through the Cert Manager Helm chart, the values would be hundreds of lines, but I only need like these 10 changed. So what this is saying is, hey, please create Kubernetes custom resources, use Cloudflare for resolving certificates manually, because this is going to be a private cluster that only works on my internal network, but the domain name needs to be public. So if I tried to resolve vmoff.local.shiftsystems.net locally, I would get a local IP address. And when Cloudflare or when Cert Manager does the DNS challenge to grab the certificate, it will try to resolve it locally rather than through Cloudflare. So this is just telling Cert Manager, hey, when you go to do DNS challenges, ignore the default DNS settings and ask Cloudflare directly.
Yes.
The other thing we're going to do too is we want to turn on what is called a pod monitor. And a pod monitor is just saying that, hey, please expose the Prometheus endpoint for us to scrape, and we'll go into how we can scrape those for the internal services later.
Okay. Quick question on that one. I know obviously VictoriaMetrics is a drop-in replacement for Prometheus. If you put VictoriaMetrics there instead of Prometheus, would it barf? Like, is it?
It would barf.
Okay.
But if you are coming from the Prometheus operator, the VictoriaMetrics operator can basically translate the custom resources that the Prometheus operator makes and switch them into the VictoriaMetrics resources.
Oh, cool.
And then here's traffic. We have the pod monitor enabled again. So this is just using all the defaults, but we just want to create metrics. And then here's the star of the show today, which is going to be VM operator. So we are just changing the logging format, and we want to make sure the Prometheus converter is enabled. If we have any users in our cluster that would want to consume that, that's fine. And then we also have Grafana for data visualization as well. So now to apply that part, I have a script that just runs this all back to back, but we should probably run through it manually for the sake of learning. So what we're going to do first is we are going to grab, we are going to use the KOSCTL apply command to provision our Kubernetes cluster and make sure all the Helm charts are deployed and up to date. There we go. We're done. We have a Kubernetes.
Good. Session is over. Thanks everybody for attending.
This does take a bit longer if you're doing this with a cold start or you have like 1,000 nodes in your cluster, whatever. Yeah. But because we already baked the cake, so to speak, we're just applying diffs at this point. So this next command would generate a new kube config. So the way you access a Kubernetes cluster is you get a configuration file that contains a certificate and some information about where the resource lives. And then it spits that out into the kube config file. So then that way we could either use kubectl or tools like Headlamp and K9s for accessing the cluster. We can skip these commands because KOS already added them in the Helm chart. So now what we need to do is apply this metal-LB manifest. So we can go, let me check if I can show that on stream or not, or if it's Cert Manager, I forget. I don't want to share API keys on stream.
Why? That can be fun, isn't it?
Well, can I do a shameless plug?
Yes, of course.
We are going to see a whole bunch of examples of how not to store secrets this stream. However, my better half works at Bitwarden, and I will be helping her out at a workshop at B-Side Chicago to help everybody keep their secrets safe.
Perfect. And you're going to collect all their secrets and keep them safe, are you?
I won't be able to.
That's awesome.
Or if I do, they'll be able to rotate them faster. So
that's cool. Hey, so then if anybody that's watching this is in Chicago or will be going to B-Sides, a chance to meet Matthias and pick his brain if you're there. Cool.
Yeah, get all my secrets. So what this is doing is using a Kubernetes custom resource. So a custom resource is something that's not in the standard Kubernetes API. It's something that an operator inside of the Kubernetes cluster watches for new resources to get created. And when it sees those resources, it will render them into standard Kubernetes content. So this is creating an address pool inside of MetalLB. So then if we need to expose something outside of the cluster, we can use the IP address range 10.0.0.90 through 10.0.099.
Okay.
And then that is just creating the advertisement for that is the second resource. The next one I can't show you for sure, but that is going to be setting the secrets for Cloudflare so we can do DNS challenges. And setting the VictoriaMetrics license. And I think those are the only secrets we have for now. So let's just run through those commands super quick.
Okay, so you've obfuscated the screen. We're seeing headlamp right now as you're playing with the secrets. Yes. Is that it? Okay.
We're not playing with secrets yet.
Okay.
Okay. There we go.
I'm thinking of a funny, was it Jim Carrey movie?
Will Ferrell's a better actor, though.
Okay. and that is our debate, everyone. If you could comment if Will Ferrell or Jim Carrey, which one is the funnier or better comedian actor? Please, we'd love to know. This could settle a huge challenge or controversy we have internally here.
Yeah. So,
we have internally here. Oh, sorry, that was me.
So the next thing is we're just setting up the API token for Cloudflare as a secret and our VictoriaMetrics license as a secret. Inside of the VictoriaMetrics operator, you can define the license as a secret, so it doesn't have to be hard-coded. License as Shh.
That was a secret, Matthias.
So next we're going to go through and apply the VictoriaMetrics resources themselves.
Okay.
So if we go through this manifest, there. So the first thing we're going to create is a VictoriaLogs deployment. For this POC, we're just setting up a single because single node can handle tens of terabytes a day. And if you are running in something like a highly available K8s cluster, you could actually get like 3.5 nines of availability. So if that's all you need for an SLA and you're not sending 100 terabytes of data a day, you can probably get away with single. And if we ever needed to upgrade in the future, we can. So we're using the VictoriaMetrics operator like we talked about before, and then we're going to use the vlogs custom resource from there. We're going to name it. We're going to tell it what image to pull from the repository. The best practice for using the operator or any of our Helm charts is to version them separately. So that way, if there's a change in the Helm chart, you're not changing multiple things at once. So if there's new settings from the Helm chart, you can update the Helm chart version separate from the actual components of VictoriaMetrics you're deploying. Okay. So if you're happy with the Helm settings now, you can update the container image, or if you want to use the enterprise version or grab it from a private mirror, you can set the container images separate from the Helm chart or operator version.
A question here. I noticed that you've got API version. Let's expect out it's operator.victoriametrics.com/v1 beta 1. Is that, are there other editions of that? Like, is there V1 beta 2 or is that always going to be the final path for this?
I'm not sure when that would change.
Okay. I just didn't know if that was a choice that somebody had to make, if that was sort of another decision tree, but it seems like just that's what it is right now. No,
Yeah.
don't. Okay.
I'm guessing if there was a breaking change in the operator, this would change to beta 2 or version 1 or version 2. So this is saying which version of the operator API to use. So we have the image set up. We have our retention period. There's some arguments we can set. We'll show how to set those for other components later. And we are also saying to remove any persistent volume claims if we delete this. If you wanted to persist the data afterwards, you could just set this to false, which we'll do now. I have seen people accidentally suffer data loss events because they had this set to true, or the comparable version of that, and they deleted the resource. So the pod would delete and recreate faster, but they ended up deleting a persistent queue.
Okay. And that's a learn by, hot, right? Don't do that again.
Yeah.
Okay. So you might have just saved some people from getting burned here. How altruistic of you, Matthias.
Sometimes I'm nice. And here we're just saying to request a storage volume from Longhorn. That's 10 gigs in size. And now here's our VictoriaMetrics cluster. So here we're specifying that we're using the operator, giving it a name, all that stuff we did before. Since I'm using the enterprise version of it, I need to set a license key. You could either hard code that, which is bad, or we could use we could reference it as a secret. So the step I had to do off screen where I set all the secrets, you're just creating a Kubernetes resource definition that says, hey, this is a secret that has a key name license in it. Please grab the key from that secret.
Okay.
Here we're specifying the replication factor and retention period. And now we're getting into the individual components themselves. So for VM storage, what we're specifying here is create one replica of VM storage. You could scale this. You would scale this to the needs of your environment. Since this is a test, I'm just doing one. In a production environment, you would want at least 6. And the reason for that is if you're doing like a rolling restart or anything like that, it would cause a fraction of the data to reshuffle. And once you start hitting 6 to 8 nodes, that reshuffle is much more tolerable. So if you had a 3-node cluster and you did a rolling upgrade where you take one node down and bring another node back up, you would be shuffling 33% of your data.
Okay.
During those writes, which increases CPU and memory utilization pretty significantly. Once you start getting into 6 to 8, it's 1/6, which is like 16 or 17% or something like that.
Okay. So is that like just the safe default to go 6 or 8? But if you were to actually, is there a formula to sort of size it right? Like what are the inputs to be able to figure out, well, in my environment, it's huge. So I need 24 gigs. Like how did you calculate that number? I guess that's less words to ask that.
Yeah. So we have some internal numbers we use. For each component, there's different dimensions in which they scale, which are consistent, but depending on if you're running super modern hardware with like a bajillion IOPS, that is going to have a different, like you need this many resources per CPU core and gigabyte of RAM than if you're running on some 1-liter PC. So we're debating internally right now, actually, whether or not we should make that public. Because the problem I've had with this in the past is that how things will scale will be consistent across environments, but the numbers we have on our website will be wrong for everyone but us.
Okay. So, well, I guess we did make it public because you just talked about it, right?
The numbers aren't public.
Oh, okay. Oh, the formula's in the back. Okay. Perfect.
Yeah. So it's like so many for VM insert. This one's pretty safe, but there's so many samples per second per CPU and gigabyte of memory. If we test that on like E2 instances inside of Google Cloud, which are like Intel Broadwell, so they're fairly old machines.
Yep.
If you test that on like M8i instances in AWS, it'll still scale based on the number of samples per second you're writing. But that number is obviously going to be way different because the hardware's like 10 years newer.
Yeah. Okay.
Up to 10 years newer, but so that's kind of the struggle. Whatever number we put on our website will be wrong.
Yeah, it'll be right when we type it, and then when it refreshes, it's wrong. Right? It's just a moving target for it. Yeah. Okay.
Yeah. There's also multi-tenancy, churn rate, and a whole bunch of other stuff.
All right. And that is the sort of thing, though, like from a sizing perspective, like when you guys are helping users out, is that something that comes up? Like you guys can help them navigate that question?
We give them the numbers we have and tell them this will be wrong for your environment.
Okay.
Which is way easier to communicate in chat rather like in a high bandwidth setting like this, rather than on the website where they get the answer they want and just stop paying attention.
Yeah. Fair enough.
And I do that all the time too. That's not a, so here, getting back to the cluster, here we're setting a downsampling policy, which is, are you familiar with downsampling?
I am, but if you want to share a real quick a summary of it for anybody who doesn't know on here, it'd be helpful.
Yeah. So downsampling is trading resolution over time for disk space, and for query performance as well.
Okay, so it's like a histogram almost. You're looking at if these are all the metrics in a period, we figure out we reduce that so the granularity is different, but the overall results are the same, right? So we're basically minimizing, summarizing those data points, right?
Summarizing is not the word I would use because that would imply some aggregation. And if you did do aggregation when you downsampled, it would break counters.
Okay.
So if you have something like uptime and you did an average, you would get weird numbers.
Okay.
Because it's only supposed to ever go up or drop. And if you have a restart and you aggregate the restart with the prior sample, you could have a counter that decreased, which isn't supposed to happen.
Okay.
So the way downsampling works is we break the retention period into little windows and we pick the most recent sample in that window. So what this downsampling policy says is, I believe we're scraping the default interval, which is 30 seconds. So after 7 days, reduce the resolution from 30 seconds to 1 minute. And then after 14 days, change the resolution to 5 minutes. So it'll break the database or break the retention period up into 1 minute windows and then just drop the oldest sample. And if there's two samples at the same time, it's the sample with the highest value. Okay.
And the end result of that is reduced amount of data that's stored, like reduced amount of entries. So Correct. You're still seeing it. Okay. So it's a resource management. So you're going to get performance because you're not searching across 1 billion records. It's now being downsampled to 50 million, or just, I'm pulling numbers out of my proverbial head. But so I'm going to be faster because I'm searching across less things, right? Flipping less Correct. Stones. Okay, cool.
The other thing would be, so you're returning fewer samples in the query. And the other thing is you're saving disk space.
Okay.
So we're going to put the storage path in VM data, which is where the volume gets mounted. And here we're creating another volume claim and setting the image, and then VM select. One cool thing we do with downsampling is we make it transparent to the user immediately. So the way retention works in VictoriaMetrics is it's eventual. So things don't happen right at the 7-day mark because there would be performance issues with that.
Okay.
But when you set the downsampling period in VM select, it will deduplicate the results as if downsampling had happened immediately. So if downsampling hasn't happened yet, and I query data that's older than 7 days, rather than showing me the sample once every 30 seconds, or instead of showing a sample once every 30 seconds, it'll deduplicate down to 1 sample per minute.
Okay.
And then we're setting up a volume for the cache. So VM select can configure a cache for storing rollup results and samples, so they don't have to reach out to the storage node for as much data every query. It's super handy for things like recording rules, where they run every minute, but look back every 5 minutes. So when it runs it'll run the first time, it'll have to grab everything from VM storage, but on the second run a minute later, it only has to grab the most recent minute of data. And then we're just setting resource limits on everything else. VM inserts, the easy one to set up. We just have to set the resource limits and the version. On the last stream, we talked about using VM agent as a buffer. So what we're doing here is we're creating an instance of VM agent that's going to write metrics to VM insert. And you see it's commented out here, but we can add a relabeling rule that would apply to all samples that would go into VictoriaMetrics. And here I just set an option for debugging. At larger scales, you would want to turn this off, but I was having issues scraping traffic, and so this enables some debugging options in the VM agent UI.
Okay.
So here's VL agent. Same thing. It's going to act as a buffer, and eventually we could use it for some dropping. But for now, it's just acting as a buffer. And then here are some of the creature comforts I was talking about earlier, are the service scrapes and node scrapes. So if we were deploying this with Docker and Ansible, we would have to write a Prometheus compatible scrape config and then figure out how to pass that file to VM agent or put it on an HTTP URL or do something so that VM agent would get configured. Here, instead of having to figure out how to render a template or do something fancy, we can just create a service scrape, and then it will scrape the pods that match this filter. So we're basically saying, hey, show me, scrape all the pods that match these two labels inside of the ShiftMon namespace.
Right.
And then their metrics are going to be on this port.
By doing it this way, then, is it to help keep this clean and efficient, or is there another advantage to this way, or when or where would you use it? Not in this format.
Would you? I would use it for GitOps deployments.
Okay.
So the nice thing is now, rather than have to figure out how to inject a config file into a Kubernetes pod using like a config map or putting the file in a volume, I can just configure it the same way I configured the thing itself.
Okay, cool.
So I would use this by default. The only issue that can come up when doing it this way is if you are changing resources faster than the Kubernetes reconcile loop can apply them. But that is a fairly large bar, and most organizations would just need to set up the Kubernetes CRs.
That's what I was thinking. It sounded like that was an edge case that most don't need to be worried about.
Yep. And there's different types of scrapes. So that is scraping a Kubernetes service. This one is scraping a node, so we can get the cAdvisor metrics. So inside of Kubernetes, every container has CPU and memory uses metrics that are reported. So that way the Kubernetes API knows, or Kubernetes knows, whether or not it needs to add more resources because they have extra requests, or if it needs to kill the pod because it's exceeded its quota. So we want to grab those metrics so that I can see them in Headlamp, or if we wanted to use like a cAdvisor dashboard in Grafana.
Okay. And if you weren't grabbing those, that data it's not persistent, right? If you weren't to do this, if that pod was to disappear and you weren't scraping that, that's all.
I am not sure where cAdvisor metrics would live. The reason why I turned it on is I can go into, let's go to VM insert. If I didn't have that scrape job enabled, I wouldn't be able to configure this.
Okay.
So inside of Headlamp, which is a GUI wrapper for deploying Kubernetes, I can set up a plugin for viewing Prometheus compatible metrics. And I just have to say where inside of the cluster that lives.
And is Headlamp a pretty widely used tool? I mean, to me it seems super helpful, but is this something you discovered on, like, just happened into it, or where did this come from?
The two tools I see most commonly used are Lens. There is some licensing stuff that happened I don't want to get into with Lens. That's the most popular GUI tool. There's also a tool called Canines, which will do the same thing as Headlamp, but it uses Vim key bindings.
Okay.
So I can do a search for pods. Oop, I need to change the namespace. But here I can look for all the service scrapes and then look into the resource. Same thing, but it's whether or not you want to be a command line ninja or not.
Okay. That's where I go to break things, is the command line.
I can break things from here. The nice thing about Headlamp is if you're just getting your feet wet and you're still like learning all the lingo, it kind of lets you poke around a UI. Whereas when you use Canines, you have to have some idea of what you're looking for.
Yep.
It's kind of the classic command line GUI trade-off.
That's right. The discovery can be harder, right? If you're not into like reading man pages, an interface can be easier. And that's, I think, in an earlier one, that's where I mentioned, like with VictoriaMetrics Cloud, not to get on that, but when I use that, it helps me learn things that then I can bring to the command line if I want to use it. So I'm a rookie. So GUIs are my friend.
Yeah. Having that, trying to find a positive connotation for training tool, but like having that helper there is super nice. Yeah. I'm guessing eventually I'll start using K9S more, but right now the point and click and stumbling around is much easier. So we have some more scrape jobs. It's just scraping all the stuff we set up before. Now we're going to set up VM auth. So what we're going to do here is say, hey, we're going to create a VM auth instance. And we are going to point it at an ingress. So ingress is the fancy Kubernetes term for reverse proxy over HTTPS. And you can have multiple ingress controllers that would generate a class. So this is saying, hey, use a traffic ingress class to create your ingress.
Okay.
And then here's the host name you should use. Here are the annotations you should apply. And then these annotations will say, grab a certificate from Cert Manager. And the cool thing is if I was using like Nginx or a different controller, I would just have to change the class name. I wouldn't have to redo everything. Whereas if I was in the like Ansible world or the Docker world, if I was switching from traffic to Nginx, that is certificate management is something I just have to figure out whole cloth. Yep. And the configuration is drastically different in those two tools.
Okay. You keep bringing up the points where I've got PTSD from the last few days of me switching different systems and auth in different systems. Once I think I get it, the semantics are just different enough in each system. So this sounds magical to me to be able to one change, it cascades.
And if you want to do this, you notice all these like triple ticks right here.
Mm-hmm.
That is breaking it up into this is basically creating multiple YAML files in one. If you want the other way of abstracting that, you could use the VictoriaMetrics Stack Helm chart or the distributed Helm chart.
Okay.
Which kind of bundles similar settings to all of these into one file. So it's just one set of Helm values you have to update, and then you would just do Helm apply and you would get the cluster.
Sorry to keep asking preference questions, but if that's the case, why is this particular method what you choose to use and show?
So this is going to be less opinionated.
Okay.
I did this partially as a learning exercise, so I actually understand how everything stood up. Whereas if you're using the Kate stack, it does a lot more magic for you.
Okay.
I mean that with a positive connotation.
Yeah, but when the magician cuts his helper in half and it didn't really work, he didn't know how the trick works, right? So you're learning the trick basically.
Yep. The other thing the Kate stack does is it will manage Grafana for you. I wanted to do everything using operators, and the Grafana deployment inside a Kate stack is the Helm chart. So you can wrap Helm charts. You can have one Helm chart that uses other Helm charts. It's called subcharts.
Okay.
Where the VictoriaMetrics Kate stack Helm chart wraps the operator Helm chart and the Grafana Helm chart and gives you one place to change all those settings. It will also do a whole bunch of instrumentation for you. So that service scrape I did for getting C-Advisor metrics, it will also set up cube state metrics and node exporter. And cube state metrics is just metrics that track where inside of the cluster each pod lives. Okay. And then node exporter is just grabbing the metrics off of the CPU themselves. So the other reason you might want to lean towards the operator over using the Kate stack Helm chart is if those things are already done for you using something like OpenShift, which has like its own Prometheus embedded inside of it that scrapes metrics. You just configure that to remote write to VictoriaMetrics and use the operator.
Okay. So
the next creature comfort that the operator gives to you is going to be a VM user CR. So this is where I need to go to my own workshop and get better at secrets management. I believe you can reference these as a secret, but what this is saying is create a user resource inside of the VM auth resource that's just above it, give it a name, and then give it a credential. So it creates a user that can only access VM insert using the bearer token super secret token. Okay. This is another piece of magic. Rather than have to know the URL itself, I just say point it at this Kubernetes resource. So this is saying, hey, find the Kubernetes resource for VM cluster /VM insert, and then say reverse proxy all the traffic to that when you see this header.
Okay. Well, that saves all the problems of pathing as well, right? Like just it eliminates some fat fingers savings.
Yes.
Yeah.
Another thing too is that this can abstract the difference between single and cluster from users. Okay. So inside of VictoriaMetrics cluster, you need to specify a tenant somehow. Otherwise you default to tenant 0. But the write path is different, whether or not you're writing data to VM agent, VM single, those two are the same. And then cluster, you have to specify like /insert /tenant ID and the protocol, then the path. You can use VM auth and VM user CRs to abstract that away from the user. So they just provide their credential. It gets routed to the correct tenant. We'll go into this in another stream, but this will route the users based on a credential to a specific tenant. And you could also limit what URLs they're allowed to access.
Okay. Would that also help sort of in future if changes are made, that's one less change, like one less layer of the onion that those changes have to go out to? Like if it was manually called out, right, you would by the user, then each time that path or location is out, right? So this just eliminates the worry. This is part of the easier button that we were looking at.
Correct.
Yeah.
So if you were deploying this with like Ansible and you had a user that trashed their tenant for whatever reason, they sent a bunch of gobbledygook data and now the tenant's basically useless. What you can do is you would just change the target path suffix and what paths they're allowed to access. They could use the same credential, but they would route all new writes to a different tenant.
Yeah. Okay.
So we create a few more users. One of them is going to be for writing logs.
I love the bearer token name, by the way. Was that voted on by the...
You can tell they weren't randomly generated.
Yeah.
It's a coping mechanism. If I get angry when I set stuff up, I start using silly names for things. So yeah, we have more VM users. Some of these were set up for other demos. This is going to be our select users. So again, we don't want users to have to type in to get to VM UI. We just want them to go to vmauth.local.shiftsystems.net/VM UI rather than having to type out. My brain's too smooth to remember that many slashes.
Oh, exactly. And inevitably you just try to go into the root and go down. Yep. I like your thinking, Matthias.
So we have more users that are setting up insert for that as well. We also have the ability to set up alert manager. So again, using the comparison between like deploying this with Ansible, our Ansible playbooks don't deploy Prometheus alert manager, whereas our operator, that is in scope for that. So now we're deploying VM alert, which is our rule engine. And it's something we could also view from VM select as well. So we're deploying the enterprise version. We're saying, hey, this is the resource you should use to pull URLs to, where to write the results from, and where to send notifications to. So VM alert just evaluates if something is wrong. It doesn't determine where notification should go.
Yep.
It uses Prometheus Alert Manager for that. So Alert Manager has silences, inhibitions, everything we talked about in the alerting stream.
Mm-hmm.
And that is what will wake you up at night, not VM alert. Here, what we're doing is we are setting up the ability for VM alert to send links inside of the alert rules. So if you, by default, the alerts that you get from Alert Manager don't have a whole lot of context attached. It just spits out the labels at you and it doesn't give you anywhere to go to actually look to see why the problem's happening. When you add in these arguments here, it's saying, hey, here's the link to the external URL and here is how to attach a query to it.
I got to admit, looking at that alert source line there, I think I've sweat. I'm going into the deep end.
Thankfully, this is in our docs and you can copy it.
Okay, perfect.
So this is just setting the query parameters to give you the correct data source, the correct way to escape the query so it gets URL encoded. And then the final creature comfort is going to be a VM rule. So what a VM rule is that it creates rules inside of VM alert for you again. So I don't have to do that inside of Ansible and render some YAML file or render some Jinja template as my alert rules. I can just create a rule as a Kubernetes resource and do everything in one file.
Nice.
So now we can go to my handy shell script.
So that's all the config to get it up and going, right? Like, so we've walked through that process and now your shell script is going to, this is where it runs or not?
I cheated again. We pre-baked the cake.
But even if you pre-baked it, like, so running that command, it read through your YAML file, it pulled from the other configs, it deployed VMauth, VM insert, logs, VictoriaMetrics itself, all set up, and it's just running now, right?
Yep.
So now when you say you baked the cake and it went a little bit faster, how much faster is it because you pre-baked it? Like if you ran that just fresh out of the get-go, does that take a minute to run? Like, cause that started up so damn quick.
It's a few minutes.
Okay. So
and you might have to run it twice.
Okay.
There's some ordering things too. Yeah. So because I'm doing everything in one go, I'm not sure if some of the, I'll call them creature comfort resources like VM user and VM rule.
Yeah.
I'm not sure if the VM agent CR has to exist for those first.
Okay.
I'm just deploying it all in one shot.
Yep.
And redeploying it again.
Sorry, I didn't mean to talk over you there, Matthias. Sorry about that. But Now, is this output telling me that it deployed everything that you had in there, but is that validating also that it was deployed correctly? Or is this, or what I'm seeing here is just, I started all of these up, but I mean, something could be borked between like your users or something, or is that, or when it gets to this point, does it mean it's running as expected?
So what can happen is that it created the Kubernetes CRs to do everything.
Yep.
But when the operator sees it, it can fumble on something.
Okay.
So you could have misconfigured the Kubernetes CR and it was valid enough to get created in the cluster.
Yep.
But the operator goes, "What did you just give me?"
Okay. Yeah, and with validate, I'm thinking back to, again, my caddy nightmares. I do caddy file validate or caddy validate, and it just goes through and tells me, hey, you screwed up on this configuration file. Is there anything similar to that, to validate that YAML that you just did? Or is it just you run it, and if it works, it works?
Let me check kubectl dry run. There is a way to do dry runs for applying.
Okay.
So if I just do I can dry run that.
Okay.
That doesn't solve for it created the CRs, but there's something screwed up with the CR that's causing the operator to have problems.
Okay. Cool.
Last bit, we're getting close to time.
Yep.
We can deploy Grafana with the operator too. It's just same idea as applying values. We set up data sources in there as well. We might want to go into more detail about that later, but same idea. We have an operator. We can create the Grafana instance itself. We can create the data sources and install plugins as well.
Yeah. So now we can see it. Like, how do you see it running now? Like you showed me it here. Is it real? So that could just be a shell script to output standard output, and I wouldn't know.
You know me, I like to bamboozle people. So the answer is yes. So let's go to VM auth, local VM UI. So yes, it works and it has bugs.
Nice.
I don't know why it redirected, but so here, if we go to VM UI, there we go.
Wow.
So now we don't have any, we also have Grafana set up here as well. And I think I have.
Now this is super tiny, by the way, Matthias. This is like, what is this, a school for ants?
What is this, a font for ants? So if we wanted to explore our dashboard, we can see the alerting overview. I think we have the cluster. Do we have it? I can go grab it quick. So let's grab the VictoriaMetrics cluster. VictoriaMetrics cluster dashboard.
So as me being somebody who's supposed to stay in the shallow end of the server pool, if I had your YAML file there and I executed it on mine, and if it worked on yours, therefore I would be able to deploy my Kubernetes environment. Away I go.
You would have to change some particulars, but yeah.
But yeah, okay. I'm going to be dangerous now, everyone.
We're going to have the biggest GKE bill ever next month, I swear.
Yeah, and just wait. I'll call our support team day and night.
Worst customer ever.
Oh yeah, for sure.
So now if we import, we see that we're ingesting 645 million samples per second, and we have 30,000 series of cardinality and the available resources in the cluster and just kind of how everything's doing.
That is slick, honestly. Now, for us non-initiated Kubernetes folks, right? They're like with my side that understand what it is, but not really why. I'm looking at this going, okay, so if you were only to deploy this one time, yeah, you do it manually, but in here this is for CI/CD, for pushing out changes. Like this just makes it easy to have this a repetitive automated system now. So it is up, it's monitored, and I can keep the deployment fresh. Is that right? Or have multiple deployments?
Correct.
Okay.
And there's also specific tooling for managing Kubernetes deployments. So what I'm doing is the like troglodyte way of deploying Kubernetes. The proper way would be to use something like Argo CD, which will sync what is in a Git repository and with reality.
Yep.
And if things that were manually provisioned, it will clean them up, which is the polite way to say get rid of them for you.
Okay.
So if I go in and decide to circumvent the GitOps process, Argo CD will keep you in check.
Okay, cool.
There's also Flux, and I think there's other ones too, but
so that comes down to the standard thing of there's a million ways to do it is the good thing, and the scary thing is there's a million ways to do it, right? So it's sort of pick the tools that you're familiar with or have people to help guide you through, right?
And the most important thing, if you ever get stuck with tool shopping, is to make sure that solving the problem is the important part.
Yep.
Tools secondary. So if you already have Flux, is it worth migrating to Argo CD? Maybe, maybe not. Yep. But deploying things with GitOps is something you should be focused on.
Okay. But then other than with the tools, it's like in my photography world, you shoot Canon or Nikon, it's whatever you like, right? They both take pictures. I like the menus in one over the other. Well, that's awesome. Now, I know that we are coming up to time and there's more stuff that we wanted to cover in here. What do you want to should we outline what we wanted to cover and we can take that in the next session, or do you want to try to shoehorn into here?
I can shoehorn ingestion just to prove that it works. So
proof.
That dashboard that we had is showing stuff that is running inside of the cluster, right?
Yep.
But we haven't proved that we can get data from outside the cluster to in. So we're going to use that same credential that we had before. I wrote a script called insert.bash, which is just running a curl command. So I could either run the script or just grab the curl command. And I'm going to use that same super secret bearer token. I think it got screwed up on the line ending, but we'll just run the script. And now we can see that everything went swimmingly. Curl didn't give us any output errors. And now if we go back to VMUI, we can look for any metric with the name measurement in it. Thank you, autocomplete. Why did I forget how to type? We are coming up to time.
And while Matthias is typing, before we started this, there was some real fast typing to try to get a few things fixed. So it's been calm all the way through.
So here we can see that those measurements that we were writing.
Yeah. That's awesome. So they're cool.
So next week we can go over a bit more into multi-tenancy and doing real data ingestion, because most people aren't using curl as their telemetry shipper.
Fair enough. Okay, so yeah, I think that'll be great. So then we start to get into the rest of it. Yeah, we'll start to figure out how to ship more in, what some other ingestion models are, and then what else will we be covering that? Like that's what we're gonna catch up on next session. But what's the focus, the original focus of next session before the add-ons?
I believe next session was supposed to be data ingestion for a given customer.
All right, perfect. And honestly, I think that was a really good tour for this one, Matthias. Thank you so much for being able to explain it to somebody that's very smooth, polished brain like myself. And I'm sure that looks like a lot of the others attending, I'm sure that learned some information as well. So I'm looking forward to that session next month. And then you and I and a bunch of the rest of the team are going to be in Atlanta in a week and a bit, right?
Yep. And I will be speaking at Cloud Native Rejects talking about AI stuff.
Cool. Awesome. So yeah, again, everyone our team is out and about literally all over the world right now, involved in different community events, other conferences. So keep an eye on our website and our social media to see where our team is going. Everybody from our side that goes out and does talks and meets with users would love an opportunity to speak with anybody about how we look at PaaS or anything in this space. So Yeah, that was awesome. Thank you so much, Matthias. Thank you, everybody, for attending. We will, again, this will be, we're going to have a breakdown, a follow-up blog on this, and maybe some links to some of the bits that, Matthias, if there's any files or things that you want to share in there, would be awesome. But anything you want to add, bud?
Nope, you did a great job. Look forward to seeing everyone at KubeCon.
You don't have to lie. Awesome. Thanks, everyone. We'll talk to you in a bit. Ciao.